talk about Node and Express. So Node is nothing but a tool that allows us to execute JavaScript on a desktop, right? As opposed to executing JavaScript on a browser. Whenever you think of JavaScript, immediately you think, well, this is a script that is executing on a browser. It has access to the browser's DOM. It has access to the window. It can do pop-up alerts. You can listen you can bind it to all sorts of event handlers as users click on buttons and type on the keyboard. And that's certainly true, right? That's where JavaScript is mostly known for. But certainly it's much beyond that, right? JavaScript it's a language that happens to be has had its success on the web, right? As a means of interacting with the browser, right? But certainly that language, as a language, right, it can really be run or executed in any other framework, right? And in particular, we'll see how to execute it inside of on a desktop, right? And you might say, well, what's the point? Well, there's a lot of things that you can't do, that JavaScript can't do when it runs on a browser, right? Well, there's a lot of things that it can do, and there's a lot of things that it cannot do, right? Certainly can interact with a human being, right? It can respond to human input. It can alert. It can change the view. It can change all these things that are deal with humans, right? But it doesn't have access to data, right? For instance, it needs to go back to some server who's hosting the data. It doesn't have access to the file system, right? It has limited access to the network. It only presumably just talk back to the domain where it was downloaded from, right? Otherwise, it's considered to be a cross-origin security liability, right? That we don't typically allow scripts that are downloaded from one domain to go and talk to some other domain, right? And that's why we use CORS to allow this explicitly. So JavaScript running on the desktop, it's very nice because it complements a lot of the things that you cannot do on a browser, right? So the JavaScript running on a desktop has unfettered access to the network, right? It's not running on a browser, so it doesn't have any of the security constraints that JavaScript might have running on the browser. It has full access to the file system, right? It can communicate with a database, so all the things that you can do when you're executing on a desktop. Obviously, it doesn't. Just like it complements the things that you can't do with JavaScript on the browser. You can't do the things that you can do on the browser. There is no window, right? There's no input field. There's no UI, right? There's nothing to pop up. There's no DOM. There's nothing, right? The browser doesn't exist. It is exclusively running on a desktop machine, and it has all the access that you could have with any other language, right? Running on a desktop. Okay. So they complement very nicely, right? The things that you can't do in one, you can do in the other. Obviously, the main way of these folks the way to collaborate with JavaScript running on a browser and JavaScript running on a server will still be the main communication will be HTTP, right? And sharing JSON data across the AJAX calls that will integrate these two. Right? Now notice that some of the complexity that we might have had in previous, by using Java on the middle tier and using JavaScript on the client, a lot of the complexity will go away, right? So because now you have both using JavaScript on both ends of the HTTP connection, there's really there's very little transformation that needs to be done, right? When these two layers need to talk to one another, right? Whereas in Java, some of the data types are not supported, or Java has a much richer, strongly typed language, right? And whereas JavaScript has a much narrower set of data types, that transformation or any of those concerns on how do you convert from one language to another language, that goes away, right? Although it wasn't that a big deal, right? We had the add request body, doing a lot of the work for us of mapping a Java data model to a JavaScript data model, right? But it'll become even even more ubiquitous, or maybe much easier, right, to go beyond between these two layers. And it'll become even more apparent when we have MongoDB as a database, right? Where now you'll have JavaScript and JSON, all across the entire stack, right? It'll be even more dramatic when we introduce MongoDB next week, since a lot of the conversions that happen between Java and a relational database, that conversion will go away, right? The fact that Java is object-oriented, it can have objects within objects within objects, implementing all sorts of many-to-many, one-to-many relationships, and that these are implemented in relational databases quite differently, right? That there's a conversion between these two, and we have a technology that does that, the ORM, JPA, right? And JPA does a conversion between a flat world of relational databases and a very hierarchical world of Java object-oriented world. Yes, and there's oftentimes this ambiguity on how to do the conversion. Like for instance, inheritance. Right? Java objects, it's inheritance is a very common way of splitting up the data model, whereas this is not at all supported in relational databases. Right? So there's all sorts of ways of implementing it, whether it's one table, multiple tables, joined, one table per class. There's a whole bunch of different ways of doing it. Also, Java and the way you implement the parent-child relationship is usually parents have knowledge about their children, right? A parent might have an array of children, whereas you encode this in relational database, and the other way around, right? It is the children who have references to their parents, right? So all this ambiguity of how to represent the data models in one world and how to represent it in some other world, the mapping between these two worlds was automated by JPA, right? And so all that's going to go away, right? So once we have JavaScript and JSON, across the entire stack, right? A JSON object can live, in any of these three spaces, right? Equally well, right? There's no need to convert. There's a JSON object on the client can go to the server, can go to the database and back, right? Without any need for conversion. So we'll, JavaScript is becoming it's like taking over the world. One language to rule them all. Yeah, so let's talk about Node.js. So Node.js, as I mentioned, is it's just a command line executable that you can download from Node.js.org. You probably already have it installed in your machines since we've been using React, right? So React uses the Node.js framework, right, to run the create React app, to do npm start, all those. So we've already been using Node.js to some extent, right? But we haven't actually programmed in Node.js, right? We've programmed in JavaScript on the client, but now today we'll introduce programming JavaScript on the desktop using Node.js, right? So Node.js is just that, right? It's an interpreter. It's a JavaScript interpreter that allows you to create a JavaScript file, right, with the same types of commands that you would expect in JavaScript, and then just saying node. Just say node, and then the name of the file, and then it executes locally, like this simple hello.js. It might have a a console.log, hello, and then it just prints out hello to the console. It's trivial as that. So when you do install Node.js, there's at least two executables of interest. There's Node, right, which is the interpreter, and there's npm, which we've been using for a while, right? And npm, just as a reminder, right, it's a Node's package manager, right? It allows you to go out and download libraries from a repository, right, and install them locally or globally, locally on a particular directory, or globally, so it's accessible everywhere, just like we did for Create React App. That's how we installed it. We use npm, right, and install Create React App globally as an executable across. We also used it for installing Angular last week, right? We used npm. And we'll be using npm quite a bit for managing these packages. So yeah, those two executables, Node and npm, we'll be using quite a bit throughout the rest of the semester. So this is the stack that we're going to be spending from now on, where we have something that is so light you can't see. Why is this so light? What? There you go. So this is the stack that we're going to be spending the next couple of weeks. We have Angular running on the browser, right? Which is just plain old JavaScript. It's a framework written in JavaScript with its own component, a user interface. It has a data model representing its own data, and then it has services, client services that are going to be using, communicating with the middle tier using Ajax, right, over HTTP. On the Node.js, we're going to have a RESTful service, just like we have in Java. We'll have a RESTful service, but implemented in Node. And to implement that RESTful service, we're going to be using the Express library. Now, the Express library, you'll see it's trivial to create these RESTful services. A single line, and you're done. You have a RESTful service. It'll have its own data model, right? Its own schema representation, and then next week we'll introduce Mongoose. Mongoose will be our liaison to talk to a non-relational database, MongoDB. Right? That it'll be a driver that can talk to the native database and exchange JSON back and forth, read and write JSON to the file system, and into what are referred to as collections in the Mongo database. Right, so this is the stack that we're going to be spending for next 3 or 4 weeks. Alongside, Angular is also going to be talking to a Java middle tier as well for read only, but it's going to be mostly read and writing to a Node.js middle tier. All right, so let's create our first Node. Let's see. So let's go to webdev, and let's go to 2019. And so up to this point, we have a Java middle tier. So we can create a Node.js middle tier. So let's do that. So we can do a make directory, and so it's a webdev. This will be a server as well, but instead of a Java server, it'll be a Node server. Okay, so if we go to the server, once you're here, you can create a Node project. Right. Now, up to this point, we've already been using Node projects, right? But they have been created for us. Right. All the Angular projects, those are Node projects. The React project that we've created so far, those are all Node projects. And the way to create it is simply using npm init. So npm and then init. So npm init is going to go into asking, what's the name of the project? Who's the author? Is it connected to some GitHub repository? Does it have some licensing and all those sort of things? So I'm just going to accept the defaults here: description, entry point, test command, Git repository, keywords, author, Jose Annunziato, license. Is this okay? And so what it creates for us is a package JSON file. So this is what makes this a Node project, right? That it has this particular file, right? Just like in Java, what makes a Java a POM project, right? A Maven project is that it has a POM file in it. That's all it makes it a Maven project, right? That it has that particular file. The POM file and the package.json file are basically synonyms to each other, right? Whereas POM describes a Java project and all its dependencies, package.json describes all the dependencies for a Node project, right? So, for instance, whenever you install a new package, right, it would be recorded in this package.json file, right? So the first package that we are interested in is the Express package, right? The Express package. This Express it's a library. It's a Node module. that will allow us to create servers very easily. So just like any other language, right? A language all by itself is not very interesting. What makes it interesting is all the libraries and all the source code, all the open source and the community, right? That makes that particular framework vibrant and really cool to belong to. So Express is one of those great libraries that is highly used and that we're going to be using for the remainder of the semester. There we go. So it install Express, and so if we look at the package JSON, you'll notice that it will have introduced a dependency there. See that dependencies that was not there originally, right? It added this dependency, and the reason it did it is because when we installed it, notice the -- save there. See that -- save? So that automatically adds this package as a dependency in package JSON. Right? So don't forget to do the -- save. If you install it without -- save, it'll install it locally, but it won't record it as a dependency. Right? And so you'll get it working locally, works fine, and then when you deploy it in Heroku, it's not working. Right? And people will say, well, why it's not working remotely? Right? And the first thing we'll ask you is to check your package JSON. Are all the dependencies listed there? Okay? Because what package JSON is going to do, notice also that node_modules, it created that file there, this directory. All those libraries, the Express library, are copied and downloaded into the local node_modules, right? And so Express is in there. Express is in there, plus all the dependencies of Express. Express needs a whole bunch of other libraries. It'll walk the dependency tree and it'll download all the dependencies that it needs. So Heroku, what Heroku will do is it will parse your package JSON and see what all dependencies are there, and it'll do an install. It'll do an install. If the dependency is not listed in package JSON, then you won't have the library that you need. All right, so it won't work for you locally. So if I do a remove of node modules, and it's gone, right? What Heroku will do, it'll do an npm install. It'll do an npm install, which will parse your package JSON, right? And it'll download all the dependencies and recreate your node_modules, right? Which there, right? But if you don't have it, the dependency, then it won't download it and it'll fail remotely. So make sure the dependencies are there. All right, excellent. So we have that. So let's create our first file here. So let's do a touch hello.js, and we can open it up with our favorite IDE. And let's open up the project we just created. It's under webdev, 2019, spring, and no, there it is. So let's open that up. And the only thing we have in there is our hello file, right? It has an .idea, and so let's that's the IntelliJ's idea file that we want to ignore. We don't want to put that in source control. So let's see, hello. We can just type in something silly. So console log hello world. And we can save that, and then we can just node hello, and then it prints out hello world as you would expect, right? So that's what node is basically, right? Being able to run JavaScript files on our command line. What we really want to do is create a server, right? We want to create a server. So let's create a brand new file here, and so we can create here a new JavaScript file. So server.js, and it's currently it's empty, and we want this to run just like we have a Java server. We want a Node.js server, right? And we want to have
web services and access to a database and expose the data model and whatnot. So let's do that. So we're going to be using the Express library. We can load the Express library by saying Express require. Express require is a Node.js keyword, right, that allows you to load or import modules, right, that are already in your node underscore modules. If it doesn't have a period slash in front of it or anything like that, it will first look inside of node underscore modules, right? It will try to find this library, right, and it first starts by looking in your node underscore modules. If it finds it, it's done. Right? If this is one of your files, you can also require it, but then you'll need to. Typically, you won't put it in node underscore modules. Typically, you can include your hello.js. You can var hello. You can require any of the other files, but then you need to do a // and tell it exactly where it is. You start looking in the current directory and then find the other file. Right? In this case, we are retrieving hello. Notice how it found hello. Notice that the file ends with .js, right? But .js is optional, right? It's implied that this is a JavaScript file. So notice that it does not include the .js at the end, right? It's implied that it's a JavaScript file, so it does not include it. Anyway, so this actually won't work. For something to be able to read something in some other file, right? That other file needs to be able to export something, right? Very much like we did in React, right? We had classes talking to one another. One had to be able to import only if that other class exported, right? So same thing here. It's a very common module management technique where some module exports something and then somebody imports those. In this case, hello is not exporting anything, so we can't really require anything. Let's keep going. The other thing here is that Express, the require here, that require really what it returns. That require what's being exported, right? It's what's being exported is a function, right? So Express is now referencing that function, okay? And that function, in this particular case, is being treated as a constructor, right? So that Express parentheses, it's as if creating a new instance, right? And whatever it returns, right? Typically, what it'll probably return is a JSON object, a map that maps to some function that live inside of that function, right? Inside of that class. And that what we're going to do is that we're going to bind it to a local variable called app in this particular case, and that is going to be our entry point. That is going to be our entry point to the application, right? This is a server-side application, right? So that's why we're calling it app. It's a very common name, right? So this is the entry point for the application, for the server application. Okay. Next, we can having app. You can now describe or declare what are called routes, right? Or URL patterns by which you're telling the server what to serve, right? If you see this in the URL, respond like this, right? If you see this request, send this response. This request, this response. This request, this response. Okay? By default, out of the box, you have to declare every single request and provide every single response. Right? Later on, typically what we'd like to be able to do is just maybe declare a public directory and everything that's in that public directory just be served automatically, right? We'll do that in a minute. But out of the box, right, every single response needs to be mapped to a particular request. Right? Here, we are declaring a request. We're saying if you see a GET request, an HTTP GET, that says app.get, right? If you see an incoming GET and the URL right, is /hello, then you're going to call this function request response. Right? And you're going to call this function, and this function, what the .get does, what it's going to do is it's going to parse the request. The request is one big string that comes from the browser or from wherever, right? It comes one big string, and in that string you'll have cookies, you'll have headers, maybe you have a JSON object embedded in the body, maybe a file that's been attached to the request. It'll have maybe a timestamp.
It'll have the URL or the IP address from the machine where this is coming. There'll be lots and lots of data in the incoming request. Yes, right. So what the .get will do is that it will parse this. It will parse all this information from the incoming HTTP request. Okay, and once it's done parsing the request, it will call a function, whatever function you give it. Right. It will call your function, and it'll pass you the first argument. The first argument to this function, it will pass you that object it parsed, right? The IP address, the timestamp, all the cookies, any files if they're trying to upload a file, any form that was submitted, right? Anything that comes from the request, from whoever sent this. Make sense? Right? So that's in the first argument to that function. The second argument is a object that you can use to generate a response back. Right, where you can send something back to whoever requested this. Right, together with the request and response, right, you can write applications that can participate in the client-server application. Right, you can read an incoming request and then generate a response. The most common type of client-server application that you can think of. Right, that's there it is. You have we're now participating in the client-server application model. And finally, we can create we can tell the application to start listening for incoming requests at a particular port. Right? In this particular case, we're saying app, listen at port 3000. Right? So if there are any incoming GET requests with that URL, that's what I want you to respond with. Right? So let's try this out. So if we say node server, notice that it's when we did the node hello.js, it came back immediately, right? It printed hello world, and it stopped. Here, it's not doing that, right? It's now in an infinite loop, listening for incoming requests, right? So the server won't stop listening for incoming requests until I do a Control-C, right? So it's stuck waiting for the requests to come. Right? So that if I come here and say localhost 3000, right, if I say just 3000, it'll say there's nothing mapped to the slash. So this is assuming that there's an implied slash here, and it's saying there's nothing mapped to slash. That's the server's responding to me, but saying I don't have anything for you that starts with slash. Okay, I do have something that starts with slash hello. Right, and I can return to you whatever the response set to respond. Right, the response dot send hello world. Make sense? Very good. There you go. So in 3 or 4 lines of code, we have a running server. Right, it's the simplest of servers. It's so simple that it doesn't really do anything, but nevertheless, it puts the point across. Very good. All right, excellent.